In this video, we're going to learn about empirical formulas. An empirical formula is the simplest ratio of atoms to one another. So remember when we wrote formulas, we called these subscripts ratios, mole ratios in particular. And what we want to do is just reduce those ratios for the empirical formula. And that's going to help us in quite a few ways to be able to figure out what the composition of a compound is. So if we look at benzene, which is C6H6, 6-to-6 ratio breaks down to 1-to-1. So the empirical formula for benzene is just CH. All right, then if we look at, this is glucose, which is in photosynthesis. So 6-to-12-to-6 breaks down to 1-to-2-to-1. So the empirical formula is CH2O. All right, so if we look at this lead oxide compound, 2-to-4 ratio breaks down into 1-to-2. So these are our empirical formulas, which is the smallest ratio that we have of our atoms to one another. So we're going to use our math to be able to figure these things out. All right, so remember your steps. First thing we're going to do is read the problem. All right, so determine the empirical formula, so that's what we're looking for, the empirical formula of a compound that contains 1.67 grams of cerium and 4.54 grams of iodine. All right, so let's think about this. What do the subscripts in the formula represent? When we're looking at a formula like H2O, what do those subscripts mean? Well, they're mole ratios. So look at our problem. What can we change into moles? Well, we can convert grams to moles. So that's what we're going to want to do. So we're going to actually set up two different mole conversions here. Okay, so our unit plan is to go from grams to moles. And then we're going to actually have two conversion factors because we're going to have two different problems. All right, so the conversion factor for cerium, we know that 1 mole of cerium is going to be equal to 140.1 grams. All right, and our conversion factor for our second part is iodine. So 1 mole of iodine is 126.9 grams of iodine. So now we're going to use this information to do two mole conversions. Okay, so that's we're going to set this up as 1.67 grams of cerium. We want grams to cancel, so that goes on the bottom. We're going to 1 mole. And that's going to give us an answer close to 0.119 moles of cerium. And on empirical formulas, you do want to make sure that you don't round too early. You need at least 3 numbers that are not 0. Okay? All right, so over here, we'll just separate this. We're going to do the same thing for our iodine. So we get 4.54 grams of iodine from our problem. Okay, grams is going to go on the bottom. We're going to moles, so that's going to go on the top. All right, notice how things are canceling. I forgot to do that over here. Okay, so you're going to get 0.0358 moles of iodine here. All right, this is great. We've got moles now. We have a mole ratio. The problem is that our mole ratio is not in whole numbers. All right, so our mole ratio here is 0.0119 moles of cerium to 0.0358 moles of iodine. Now, we can't leave decimal points in a formula. We need whole numbers. All right, so what we need to do is get these into a whole number ratio. The easiest way to do that is just to divide by the smallest moles, and that'll give us a 1 for at least one of them. So in this problem, 0.0119 moles is my smallest. So I'm going to divide both of these numbers by 0.0119. So that's going to give me 1 mole of cerium to 3 moles of iodine. Okay, so now I have whole number mole ratios that I can use to write my formula as CEI3. So there's my empirical formula. So why don't we real quick review these steps, okay? First thing we're going to do, of course, is read our problem. We're going to circle, we're going to underline, do all those things that we need to be doing. All right, we're going to convert to moles. Then we're going to divide by the smallest moles. All right, let's try our next example problem. All right, so we have the empirical formula of a freon that contains these percentages of carbon and chlorine and fluorine. Okay, what do we do with the percent? The easiest way to take care of that is to assume that we have 100 grams. I mean, 10% of 100 is 10, right? Doesn't matter because we have the same percent composition no matter what our sample is. So if we do that, all of our percents become grams, and our problem looks like this. We have literally just taken that percent sign and changed it to grams. So now we can follow our steps to solving this problem. Okay, so let me get the right pen. So now we're going to change grams to moles. So our unit plan is going to be grams to moles, and we're going to need 3 conversion factors. So my conversion factor for carbon, 1 mole equals 12.01 grams of carbon. For our second one, our chlorine, 1 mole of chlorine equals 35.45 grams. And for fluorine, 1 mole equals 19 grams. I'm sorry, I'm almost out of room over here. All right, so we set up 3 mole conversions. So 9.93 grams of carbon. We want grams of carbon to go on the bottom. Oh, sorry, that keeps moving. Let me get rid of that. Okay, so we got 12.01 grams down here, and we get an answer of 0.8268 moles carbon. All right, we're going to do the same thing for chlorine. So start with our given for chlorine, 58.6 grams of chlorine. We want grams of chlorine on the bottom, moles of chlorine on the top, and I'm just going to write this down here since we need a little bit more room. We get an answer here of 1.653 moles of chlorine. We're going to do the same thing over here. We get 31.4 grams of fluorine, grams on the bottom, moles on the top, and we get 1.652 moles of fluorine. Okay, so now we have our ratio. Get the right one? Okay, so our ratio here is 0.8268 to, let me erase this, get out of the way, to 1.653 to 1.652. All right, which one is the smallest? The 0.8 is the smallest, so we're going to divide each one by 0.8268. We get 1 to 2 to 2. So our formula is CCl2F2. Okay, now this example is not on your sheet, but we are going to go over it in class, so just jot this down. Remember to change your percents to grams, and we will go over it in class.